Good morning. It is still morning just. My name is Simon and this is Suneeta, and we're here to talk about continuous delivery on Kubernetes. That's a much simpler title than the official one up there. It's quite a mouthful. I'm not going to try to pronounce it. So I'm going to talk about the journey that we went on through, looking at all the different options in continuous delivery at Nearmap, what worked for us and what didn't. Suneeta's then going to talk about the solution that we ultimately came up with, which we have since open sourced. So as you might be able to tell from our accents, or not, but we're from Australia, so thanks for having us here. And this is a picture of the Sydney Opera House for you. But it is a top-down picture of the Sydney Opera House because we're from Nearmap. We do high-definition aerial photography from aeroplanes, none of this satellite garbage. Sorry. And then we make that available online through various services. And we do a lot of 3D modeling and machine learning around that as well. We're not in Europe, though, unfortunately, yet, which is a shame because I'd love to see some of that amazing European architecture up there. But like a lot of content providers, we store terabytes of data in the cloud in different regions, depending on where we capture that data. We run Kubernetes in each of those regions, and we run microservices in those clusters, exposing a whole bunch of different APIs. We also run multiple clusters in each region for things like testing environments and developer playgrounds, and we do continuous delivery. We deploy software out multiple times a day. So as you can imagine, this is a lot of services that we need to manage and deploy. Kubernetes doesn't really help us with this. It specifically says that on their webpage. And it says that CI/CD workflows are determined by organization cultures, preferences, as well as technical requirements, which is a fancy way of saying that there's no one-size-fits-all solution for this stuff. And it's a bit of a shame because it is pretty easy to set up a Kubernetes cluster these days, but setting up a CD pipeline to go along with it, we've found is not so easy. So we started off a lot like most people probably did. We used kube control to deploy our pods out. We'd define a container in a configuration file, use the latest tag and deploy that out. But using the latest tag is not such a great idea, we found out. So we started parameterizing our configuration files, storing version numbers inside those. We use Git hashes for our version numbers. We're talking about deploying internally here, so we don't need the overhead of Semver. But we have to manage that per cluster because they're all running different versions. And this is all very manual. So we want to automate this with a CD pipeline. Here, illustrated as a series of verification steps that our software passes through on its way to production. And that's just to ensure that it's fit for purpose. The left side of this pipeline is well understood. People have been doing continuous integration for quite some time, doing builds, unit tests, and getting those feedback loops in place. On the right-hand side, the actual deployment out to your production environments, doing verification there is not so well understood, and that's what we're going to focus on today. A lot of organizations already have their own build servers, such as Jenkins. There are plenty of other good ones as well. So here's a high-level view of a typical CD pipeline, just looking at all the main actors involved. So we have our developers pushing code to a Git repository. Jenkins pulls that in, builds it, creates a container image, pushes that out to a container registry. Now, we need to set up some kind of workflow in Jenkins in order to do the deployment, and it can do that using kube control or talking directly to the API server. We need to set some access controls in Jenkins. But that's okay, it's part of our infrastructure, so we trust it. So it does the deployment, and then our clusters ultimately pull in the container image and create the pods. But we need to set up a Jenkins server and maintain that. So what we're calling these managed build tools, these seem to be becoming a lot more popular because they're just so easy to get up and running. We use Circle CI, but there are plenty of other really good ones out there. So to get up and running, you just commit some configuration to your Git repo, you link your repo to the tool, and you're off and away. But the problem here now is that when we want to set up the similar sort of workflows to do a kube control deploy into our clusters, we need to expose our API servers or the control plane of our clusters essentially to the world because these services run in the cloud. We also need to store those access credentials in these third-party services. Now, this is not ideal because these are our production services potentially containing sensitive customer data. So let's look at some other options. Now, normally I'd run through these in a bit more detail, but I don't have the time. I'm going to skim through them. But generally, these are all very good tools. They just happen to focus on different things that didn't quite fit our requirements. But I will stop on this one because this is quite close to what we were after. Weeflux, you may have heard of it. Here, our pipeline is building container images, pushing those to the container registry. Now, we have some sort of config updater that's monitoring that container registry for changes. And when it detects those, it pushes the configuration changes out to a Git repo, which is a configuration stored there for our cluster. Another process running inside the cluster, a deployer, then detects those changes out there, pulls the config in, and initiates the deployment. So let's talk a little bit about this approach. You've probably heard it as well. It's been mentioned a few times, this GitOps idea. And there's a lot of advantages to using GitOps. You've got all of your cluster changes in config history, and you can restore your cluster to any point in time. But our experience of storing version numbers specifically in source control is that it is very noisy, and it tends to drown out the rest of your configuration history, which is arguably a lot more important. So we're not against storing configuration in source control. We do that. We store a very simplified single version of our application configuration alongside the source code. And we do that by removing all the cluster specifics from it, by using things like Kubernetes DNS and external services allow you to do that. So if you're not, again, storing your configuration in source control, how do you deal with things like version number, history and rollback? So rollback first, we find that if we're delivering very frequently and doing small updates, that rollback is something that we very rarely need to do. We tend to roll forward when there's a problem that's gone out to production. And because it's a small change, we generally know what the issue is when it's gone out there. So we'll cut a new release, push it through our CD pipeline, which is completely automated, and then get a fix out into production. If your pipeline is manual in any sort of way, then that's going to be a lot harder to do because the turnaround time is not so great. So again, we're not saying that rollback isn't necessary. We just don't need to necessarily optimize for that. So we would tend to roll back by cutting a new release on an older commit and then just pushing that through our CD pipeline. Again, because it's all automated, we can turn around that very quickly. Finally, the history. History we store inside the cluster itself, the version history. And we find that's okay. The main problem with doing that approach is if you did happen to lose that information somehow, if your cluster failed, then you've kind of lost that history. But we store all of our master branches represent the current version of all our software, so it's easy to restore. So none of these tools really fitted what we were after. So we kind of went back to basics and said, okay, how can we create a really simple CD pipeline, and what would that look like? So first, let's define some goals for this pipeline. We want to be able to bring our own integration tool. So these are well-known solved problems, right? People have been doing integration, continuous integration for some time. We don't want to have to use any additional infrastructure. So we already have our build server, we have our container registry, and we have our Kubernetes cluster. That should be enough for us to build a pipeline. We want to utilize existing Kubernetes concepts as much as possible, right? So we're invested in the platform. We want to make whatever use of that we can to our advantage. And we want to focus on supporting the full automation, although we do want to be able to allow manual steps where needed, but we're aiming for that full automation. And finally, we want to support best practices in the industry. So we want our environments to be secure. We want to be able to do verifications as we do our deployments through things like blue-green deployments. We want to be able to store version history and rollback, and we want good visibility into what's going on in our cluster. So we want to be able to see what versions of our applications are running, when rollouts are happening, and of course, when failures occur so that we can respond to them. So a simple pipeline might look something like this. So again, we're building container images. We're pushing those to a container registry. Our cluster is pulling in the images as well in order to create pods. The difference here is we're now pushing version information directly into the container registry. And we have a service running inside the cluster that's monitoring the container registry for changes and initiating deployments when it detects those. And because this is a service running there, we can add a lot more smarts to it as well. So we can start doing verification steps as part of the deployments. It can store the version history that we're talking about. We can also expose an API so that we can interrogate the state of the cluster and find out what's going on. So the advantages of this approach is that we don't need to set up any additional resources. In particular, we don't need to access resources such as our cluster needing to access a Git repo, which is a bit of a problem when you're dealing with private repos. We don't need all these separate config repos around, right? We try to store a single version of our application configuration alongside the source code, and then that also matches the releases as they go out. So it's a simplified configuration, and this whole thing is easy to set up and manage. So now we're going to talk about our realization of this simple CD pipeline. So Suneeta's going to talk about that. And remember, we've open sourced everything that she's talking about, so please go away and do try this at home.
Thank you, Simon. A simple pluggable CD pipeline that easily integrates into your existing CI infrastructure sounds great, isn't it? And what would be a better way to implement the CD solution on Kubernetes infrastructure than use intrinsic Kubernetes principle and leverage on its strength? None, right? That's exactly what we thought. Enter the world of Container Version Manager. It does exactly that. It is built using Kubernetes extension point, custom resource definition, and custom controller. It also heavily relies on Kubernetes abstractions such as deployment, config maps, and many more to manage and maintain the components of CD pipeline. Thinking about it more, we should probably rename this solution that we are calling Container Version Manager to kubecd or even KCD, but we'll think about that. So let's see what container version really is. It defines a set of rules for managing container version. What you're looking at here is a CV spec example, CV short for container version. And what that declares is that my app container of all the workload that's matching the selection criteria should always be from image repository CVM example, and that it should be running a container version tagged as demo environment tag, and that this state is at max allowed to be out of date by 30 seconds. And your cluster works towards achieving that state. And it covers all the workload, so meaning all app v1 workload and also batch workload, including cron and jobs. So let's look at what makes this state achievable. There are 3 components as a part of this solution that works towards achieving that state. We have got container version controller, container registry syncer, and a set of command lines tool for you to easily integrate into your existing CI infrastructure. And this is the high-level architecture that you are seeing. Controller on the left side is responsible for managing and maintaining your CD pipeline. And the syncers, the one that's sitting in the middle that we have more than one copy of, they are responsible for managing and maintaining your workloads and making sure that they are up to date. So let's dive more into all these components specifically. First off, controller. Controller reacts to any changes into CV resource and handle them appropriately. And just like any other custom controller of Kubernetes, it uses Informer Factory for change notification. And this is a snippet from Informer Factory handle that we have. And this would probably be very familiar to all of you who have written custom controller at one point. But this just to illustrate that we are using Informer Factory for optimization point of views. The controller is also responsible for creating and updating CR syncers, and it's very smart in a way that it passes the onus of maintaining the syncers to Kubernetes by creating a deployment for it. As you can see here, highlighted in the section, it also keeps the owner references to the CV resource, thereby letting Kubernetes manage the syncers per CV resource. So to illustrate more, if a CV resource is deleted, Kubernetes will implicitly drop the syncers. And little things like that is what's making these solutions more native to Kubernetes and letting it manage itself. And that's not it. It also provides visibility on the version status or at your cluster level. That is, you can come in and interrogate for the versions of your resources that you are running in your cluster, and controller would be able to provide more detailed information on that. So just summarizing the controller here, we're sitting right on the left, highlighted with the red mark, and it deals with the API server, handles any changes into CV resources, and by doing so, it implicitly managing syncers. Syncers, they are responsible to ensure that the container state as declared by CV resource is always met, and they are the component that's sitting in the center. It does so by pulling into or talking to container registry. What it does is it pulls into container registry looking for the version of the container that's tagged with a specified tag. And once it finds the version, it compares it with all the versions that matching the selector expressions. And any discrepancy in this version check leads to a rollout workflow. So first off, we would like to validate what we are deploying and ensure that we are happy with it. Validations could be very open-ended. Some of you would like to verify, make sure that there isn't any code regression or quality checks, things like smoke tests, or even looking at container vulnerability scans or verifying the signatures of the container. So there isn't an end to what individual or organization would like to validate the image on, and that's why we have hooks for validation that you could plug in, and a successful validation would lead to a rollout operation. So as a part of rollout, what happens is the part spec of the selected workloads are patched. We use strategic merge as a patch strategy to allow for any external changes into part spec. External changes could be in terms of replica count or even resources. There are various configs that could be changed, but it shouldn't modify anything else other than version. And the rollout, as part of the rollout, the native Kubernetes strategies are honored because the syncers doesn't perform the rollout itself, but passes the instruction to control panel of the cluster, which performs the rollout. And as a result, all the native strategies are honored. If unspecified, obviously default is assumed. So native simple rollout strategies are nice, but what about when we talk about complex rollout like canary and blue-green deployments? So it's possible to use CV Manager solution to realize these sort of deployment strategies. However, in some cases, there may be a manual intervention that would be required. We are actively working on improving that, and we will look at these a bit more detail. So this is an example of a canary deployment that would look like. Here, the blue is a different deployment, and green, shown in green, is a green deployment using two different CV resources to match to the corresponding color of the deployment would allow for a separate version on these two containers. And then it's up to managing the traffic or the number of pods under your deployment to realize canary deployment. And the step of managing a number of pods is currently manual, as I mentioned earlier. And this is another blue-green deployment strategy where the segregation is at namespace level. So your services and whole solution is basically replicated at namespace level. You switch around from your DNS records based on what namespace is in production and what's on the test. And using similar approach can be used to realize these sort of deployment. We do, however, have an automated solution for blue-green deployments, but the deployment only support at this point at service level. So as you can see in this figure, this service C, the blue and green C services are using green and blue deployments. All you have to do is opt in for a strategy in your CV resource configuration saying that is blue-green strategy you are adopting to, not a default strategy, and provide your container image that would perform the validation. So that would be the container that has your system test, and it will automatically update your test workloads, perform the test. A successful test results would lead to flip of the switch where your test service will now become live. So this is very standard blue-green deployment. It's just very first level implementation that we have done for blue-green. But we are actively working on that. So mistakes happens. We all make mistakes, and they are interesting. What happens when failure happens, when a rollout fails, excuse me? We roll forward, we fix our issues, and we roll forward. That's exactly what we do at Nearmap, and CV Manager is also written with that philosophy in mind. However, having said that, it is understood that rollout doesn't, like roll forward doesn't fit all the use cases, so optional rollback is also supported, wherein you could opt in for a rollback, and if a rollout fails, then it would roll back using the historical version information that it has available. But more importantly, we notify for a fail rollout, we notify, and that could be plugged into notification in any of your notification engine, Slack or PagerDuty or any of the system that you use. So that's handy to come in and manually intervene should the need be. So just want to summarize on syncers. These are the components sitting in the middle. There would be as many syncers for as many CV resources you have. They interface with the container registry and talk to API server, and by doing that, they implicitly manage all your workloads. CI tools, these are the commands shown on the right. They just set up a Dockerized command line that you plug into your bash script of your choice of CI infrastructure. And it's as simple as just calling CV Manager CR tags add and details of your image manifest. So a simple pluggable CD pipeline should be low maintenance and easy to install, right? We have got it down to the simple one-step install only, which is just about installing CV Manager, defining your CV resources for all the workloads, and integrating into your existing CI pipeline. From this point onward, the components of this pipeline works towards achieving the cluster itself, work towards achieving this declared state itself, and they also manage and maintain themselves. So theoretically, there shouldn't be any manual intervention required, and they will adapt to the need as it would be during the life cycle. And what that leads to is a self-managed, self-healing CI/CD pipeline where heavy duty is done by Kubernetes infrastructure. Yes, this infrastructure that we all love so much. So there are several other benefits to using this. It's obviously self-managed, as we talked about, and low maintenance. This approach allows for a clear separation of concerns at all levels. The cluster, again, is responsible for managing the updates or deployments, and even the components of CD pipeline are clearly, their responsibility is clearly defined and separated. And what that leads us to is a reduced security risk and allows the possibility of using externally provided CI/CD tool where you don't have to expose your control panel or API server to external entities. It's completely open source. We welcome feedback and contribution. It's a very native solution, as I touched upon before. We do capture monitoring. We do monitor the CD pipeline, so there are various stats available, and it provides a more visibility into what's happening on your cluster in terms of version updates. So how do you maintain versions of your service? Do you have a single point of contact where you come in and ask for the current version of all your services, or even look at the historical records, or do you manage it externally? It varies organization to organization, but at Nearmap, we think it's the responsibility of the cluster to maintain that information and tell us as in what version it is currently running and what are the previous versions that it has run before. So that's why controller or CV Manager exposes several REST interfaces to explore these information. These are a couple of interfaces that we have that allows you to see the current versions of your cluster. There are JSON and HTML formats. HTML is primarily provided to integrate into your monitoring system, should you have one. And as mentioned earlier, it's an opt-in feature for release history that you can opt in. It uses config map to maintain the the previous release history, and this information is exposed on REST interfaces for your use. We also capture a variety of stats, including successful deployments and variety of failure deployment attempts. And we also send several event notifications and service check from all these components of CD pipelines, so controller syncers. And what that all leads us to is this beautiful thing we call deployment dashboard that keeps reminding us how frictionless deployment can be and how productive we are. But we couldn't do anything about the friction of the desk chair, unfortunately. So you might wonder if this approach would scale to demand, because if you're running thousands of services, then there might be equivalent number of syncers that would run in your cluster. We monitored the resource utilizations of these pods, and they were very small. This approach has worked really well for us. We think that it would work for very busy clusters as well, but we would like to see what happens when you guys try and see. We would like to hear, definitely would like to hear from you and see how it goes. So I can't finish off before talking about the best practices using this solution. We think that merge to master is one of the best practices that should be used when using CV Manager, because it's a well understood trigger and keeps your master branch a replica of your release. And like us, should you keep your config alongside of source code, that's a very good way to go back to a previous version, if at all that need arise, and also for your reference as well. If you're not distributing your services to external third parties, then we recommend using Git hashes, because more readable versions like Semver or any other naming schemes are very parallel to Git versions. The only benefit they provide is readability, which probably is not that relevant if you are releasing very frequently like us. We do recommend using dashboard. It gives us more insights into what's happening in your CD pipeline, and can tell you the strength of your pipeline. And obviously, no CD pipeline is fully automated until your services and applications are fully tested and automated. And I do want to mention that this solution is simple enough that even in our cluster, CV Manager updates itself on merge to master. CV Manager is completely open source, available under MIT license. The instructions to get you started is available on our blog, Nearmap.io. It's probably very easy to find, but the last path is CVM intro. And we also have a sample example based on this solution that would give you an idea of the kind of configuration that's required. And there is a video to get you started that's also attached to the blog. But Simon here will give you guys a quick rundown and demo of the application.
Okay, great. Thank you, Suneeta. So we're running out of time, so I'm going to try and do a very quick demo here just to show you how easy it is to get a CD pipeline up and running. So I've got a simple application here, Kubernetes configuration with that. We've got a deployment here, and we've got our container image with a version as well. We've also got a service and an ingress in here just so we can access the application. So if we look at Kubernetes, what that looks like at the moment, we're running a couple of pods in our dashboard. And then the application itself, so it's just a simple echo service that echoes back what we put in the URL, and there's a dancing monkey for some reason. But that's all good. So say we wanted to update our application. Say we wanted to, I don't know, make the message that we echo back uppercase. So normally then I would have to go and rebuild the image, push that to a container registry, do a kube control, apply all that stuff, and I get the new version. But that's very manual, so we want to automate that so that every time we commit to the repo, it will automatically get deployed out into our cluster. So in order to do that, firstly I need to install CV Manager. So we can do that with a simple kube control apply. There's also a Helm chart for it as well. And then assuming everything goes well, So what we can see here is that we've created a custom resource definition and a deployment for our CV Manager app. Now something's happened here with the config map. Let me just quickly run that again. Good old demos. We'll see if that worked that time. Okay. So now if we go back into the cluster, we're going to go to the system namespace, and we should see that CV Manager app there that's now started up. And you'll see also a Syncer pod has also started. So that's the pod that Suneeta mentioned earlier, is actually managing the CV Manager itself and keeping it up to date. So that's all up and running now. That's good. Next step is that we need to add some configuration to our application to tell it that we want it to be managed by the CV Manager. So here's some example configuration for that. We basically define the repo that we want it to monitor for changes. The tag represents the tag on the container image that is the current version for this particular cluster. The polling time is just how regularly we check the container registry. Now the selector, this is how we define what workload is actually being managed by this resource. So what we need to do is just go down to our deployment here and add a label that matches that selector. Then finally, we need to specify the container name, because obviously there can be multiple containers with different versions. So that needs to match the name of the container down here. All right, so that's all we need to do. We can now just do a kube control apply on that. Okay, so now we can see we've created the container version configuration there, and we've updated the deployment. So let's go back into the cluster. We'll jump back to our default namespace where our application is, and we can see now another Syncer has appeared, and that's now managing our app. Final step is to go into our build tool and set up our workflow step for that. So here we're using Circle CI. We have a very basic build that creates a container image, pushes that to a registry. So we just need to add an additional step here. This is invoking the CV Manager command inside a Docker container, just running the add tags subcommand. We specify the repo, the tag. So you'll notice that this tag should match the tag that we defined here in the CV Manager resource. And finally, we have to identify which actual image we're updating. So if we then go and commit all of that, so if we go to our build tool now, which was Circle CI, we should see that appear. There it is. It will start running. Now, hopefully it's not going to we'll have to build the whole container from scratch, in which case it will take a few minutes. But generally this should take less than a minute to run. And once that completes, that will have tagged the container image in the repo, and our CR Syncer should pick that up and deploy out our new application. So at this point, I should be telling some jokes or something, but not prepared for that, sorry. So that's what our cluster is currently looking like. Still waiting for the build to complete. And I think we're just going to get in before the time is ended.
Looks like Demo God is testing us.
Oh, there we go. Success. I knew we'd be fine, see? Now, so this is now polling every 30 seconds, so very shortly we should see some action here. If I'll just keep refreshing this. Oh, that's actually already updated, has it? Oh, no, oh, there we go. So we can see now it's actually doing a rolling deployment there for those pods. And that should be very quick, I think. Yeah, we're pretty much there. And if we go back to our demo application, we should see everything being uppercase. So that's pretty much how quickly you can get that CD pipeline up and running. All right, thank you.